this is the second part of our video, of our question. Question 2. Consider the diagram on the right. It shows three forces of 5 Newton, 8 Newton, and 9,19 Newton acting on an object in the Cartesian plane. Assume that the y-axis is also the north-south line. Okay, like I did before. Before we attempt any question, I would like us to draw the new free body diagram. Now resolving the vectors into components. Okay, so now let me do this. Here is our F, that is equivalent to 9,19 Newton. As you can see, this one, it is given to us, but it is not on the y or x axis. So I want to resolve this one into components. So that one is going to be, the vertical component of it is going to be like this. Let me just say this one is our F1. Is F1 V. And then again, this one, when I resolve it, it's going to be this side and this side. So this one is my F1 horizontal. Secondly, I am given this force, which is equivalent to 5,0 Newton. But this force is not drawn on the y-axis or the x-axis. So now let me resolve this one into components. For the fact that it is drawn in this direction, the horizontal component of it is going to face this way, and then the vertical component of it is going to face upwards. The method that I have used here is the tail to tail method. If I wanted to use the tail to head method, it was gonna be like this. And I was supposed to, something like this. I hope you can see what I was trying to do. So obviously for this one, let me just call it F2. I'm just going to have F2 vertical and F2 horizontal. So now this is my new free body diagram, of which is the same as this one that is drawn here. But the thing that I did here, I just took these two that were drawn out of not being on our Cartesian plane, and then I resolved them into the components so that we can also have their magnitude placed on the axis. Okay, so now let me start. 2.1 for 2 marks. Define the term vector in width. Define vector in width. A vector is a physical quantity that has both magnitude and direction, and then you will get your 2 marks. You will get your 2 marks. So my beautiful learners, I don't know what is it that is going to appear in your November final examination, but I will advise you to check the it's either they can ask you to define the term vector, or they can ask you to define the term resultant vector. So please, to be on the safe side, please do make sure that you have the definition of both of them, resultant vector and a vector. So 2 marks for that. And then 2.2, use the component method to calculate the magnitude of the resultant of 5 Newton and 8 Newton. So meaning now we are required to calculate the magnitude of the resultant of 5 Newton and 8 Newton. Meaning these two, I must determine the resultant of these two. So it is going to be very difficult for us to use this type of a diagram when we want to determine the resultant. That is why I tried to draw the new free body diagram, now resolving everything into components. As you can see, I'm having the forces that are acting horizontally and vertically. So the first step that we must do when we perform the calculations, this is what I normally do with my kids. Please do make sure that the angle that you are going to use is the angle that is measured from the x-axis. So now let's see. The angle that is given here of 45, it was measured from the x-axis. So meaning I am going to use this equation, this angle. Let's check this one. I am given the angle of 45. This angle that is given to me, it was measured from the x-axis. So now I am free to move. Because the main reason why I am emphasizing that, in order for my learners to benefit from using this equation, every time if you want to use this equation of FH is equals to F cos theta and FV is equals to F sin theta. Always, you can use always, my beautiful learners. But please make sure that when you use these two formulas, your angle is measured from x-axis. Okay? So now let's check. If I want to determine the horizontal and vertical components of this one, let me just write down here for 5 Newton. I'm just going to determine the F horizontal is equals to F cos theta. And then what is my force for this one, F2? My force there is 5. So I'm going to have 5 cos, what is our angle? Our angle is 45. And then 5 cos 45. 5 cos 45, it gives me 3,535. Okay, Newton. What is the direction of this one? This one is F2. So the direction for this one, is it to the right or to the left? It must be to the left. Okay, I am on my 5 force. Let me determine the FV. The FV for this one, it must be F sin theta. And then what is the value of F? The value of F is 5. Now sine the same angle 45. And then what is our value? The value there, as I'm pressing my calculator, is the same as 3,535 what Newton. But now let's check the direction. The direction for this one, it must be up. Okay, so now I'm done with 5 Newton. Now let me go to 8 Newton. I'm going to determine the resultant, not the resultant, the components of 8 Newton. So for 8 Newton, I'm still going to use the very same formula to determine the F horizontal. F horizontal is equals to F cos theta. And then what is the value of F? The value of F is 8. And then cos, the angle that is given is 45. And then the nice part is that the angle was measured from the x-axis. So now when I press my calculator, the value that I get there is 5,657 Newton. And then what is our direction for this one? The direction for this one, it is also to the left. Okay, so now we are still on 8. Let me determine the F horizontal, the force vertical for 8. Force vertical is equals to F sin theta. What is the magnitude of F? The magnitude of F is 8. 8 sine 45. And then obviously the magnitude that I get there is 5,657 Newton. But now, my beautiful learners, what is our direction? Our direction for this one is downwards. Is downwards. Okay, so now I do have 2 horizontals and I also have 2 verticals. So after calculating the components, I will have to determine the resultant for H, or I will have to determine the resultant for force horizontal. As you can see, I have 2 forces that are acting horizontal, and then I also have 2 forces that are acting what? Vertical. So now I must determine the sum or the resultant of these 2 forces, and then I must also determine the resultant of what? Of these 2 forces. Okay, so now F resultant for H is equals to F1 plus F2. As you can see, these 2 forces are moving to the left. Okay, let me just take them as negative, both of them. So what is F1? F1 is negative 3,535 plus into negative, what is the magnitude of this one? 5,657. And then now when I press my calculator to check my final answer, the final answer that I get here, please press your calculator, my beautiful learners. The final answer that I get here is negative 9,192 Newton. But remember that in science we don't leave our answer as negative, more especially for vectors. We don't leave our answer as what? As negative. That negative, it indicated that we took our left as what? As negative. And for the fact that our answer here is negative, we can just say 9,192 Newton, and then our direction is what? Is on the left. That is the resultant for the horizontal components. Okay, and then now let us determine the F resultant for vertical. How many vertical do we have? 1, 2. Okay, so F1 plus F2. Let us take our up as positive and down as what? As negative. So now my F1 is positive 3,535 plus into what is our F2? Yes, our F2 is negative 5,657. And then now let us press our calculator to check. I'm going to have 3,535 minus 5,657, and then our answer is negative 2,122 Newton. But remember that we don't leave our answer as what? As negative. As we can come back here, I can see that our up was taken as positive, and then our down was taken as what? As negative. So meaning as our answer is negative, I can just say 2,122 Newton. What is our direction? Downwards. Is downwards. So now we are almost there. We must just determine the resultant. I do have the resultant for horizontal, and then I do have the resultant for vertical. For now, let us draw the new free body diagram now using the resultant of vertical and the resultant of what? Of horizontal. And then you can see why I am putting the direction, because of this resultant including the direction will clearly show me on which quadrant am I going to work on. Okay, so now let me do it, my beautiful learners. I have the horizontal components. The horizontal resultant for this one is 9,192. What is the direction? Is to the left. So meaning here is my resultant. That is equivalent to 9,192 Newton to the left. So this is 9,192 Newton. Okay. The vertical one is equivalent to 2,122 Newton. Where? Downwards, this one left. So now as we determine the resultant, our resultant must be lying between the two resultant, the two forces, which represent the resultant for horizontal and resultant for vertical. So what I normally do, my beautiful learners, I normally measure my angle between I normally measure my angle from the x-axis. So now this side is the opposite side relative to the angle, and then this side is the adjacent relative to the angle. Okay, but before that one, if I want this side is our F resultant. So in order for me to calculate this F resultant, I must make sure that I use a theorem of Pythagoras. And then theorem of Pythagoras, it says Fr is equals to Fx squared plus Fy squared. And then what is our Fx? Our Fx is the one that is equivalent to our Fh. Fx is 9,192 squared plus what is our Fy? Our Fy is 2,122 squared. And then as I'm pressing my calculator, I have 9,192 squared plus 2,122 squared and then my answer there is 9,43 newtons, and then I will get my 6 marks. So please, my beautiful learners, make sure that you practice this. This is not difficult. Yes, there are so many steps, but one other thing that I can tell you, it is not difficult. As you put more of your time trying to practice, I do believe that you can get it. Okay? So now 2.343 marks. Calculate the direction of the resultant of 5 Newton and 8 Newton. Give the answer in terms of bearing. Okay? When they say that we must give our answer in terms of bearing, they are simply telling us that we must measure our angle from north in clockwise direction. We must measure our angle from north clockwise. We must measure our angle from north moving in a clockwise what direction to our resultant. Let me repeat. When they say that we must give the answer in terms of bearing, they are simply telling us that we must measure our angle from north moving in a clockwise direction to our resultant. Okay? So now, let me do this. Okay? This is our north, this is our south, this is our east, and then this is our west. This is the angle now that I'm going to look for. But the question says that we need to give our answer in terms of bearing. So in terms of bearing, we must be measuring our angle from north to this side. One other thing that I know, our angle from here to here is 270 degrees. So if I want to measure it from the green part up until here, obviously I'm going to say 270 minus the angle that I'll be getting. That's when I'll be able to get the green part, which is the angle that I'm looking for. Okay? So now let's check. The side that is given relative to the angle is the opposite one. And then this side that we have of 9,192 Newton is our adjacent side. So in terms of the trigonometric ratios, I'm having the opposite side, and then I'm also having the adjacent side. So in terms of the trigonometric ratio, the ratio that I'm going to use to determine the angle is tan. Tan theta is equals to opposite over adjacent. What is our opposite side? Our opposite side is 2,122 all over. The adjacent side is 9,192. Okay, so meaning theta is equals to second function of 2,122 all over 9,192, and then my theta there is equals to 2,122 divided by 9,192, and then my angle there is 12,999, which is equivalent to 13 degree. 13 degree. Okay, meaning the angle here is 30. But remember, I'm not looking for this angle. I'm looking for the green one. That is measured from the north up until our resultant. So one other thing that I know, from here to here, our angle is 90. 90. 90. So from here up until here, our total angle is 270. 270. So meaning I can simply say 270 minus 30 is equals to 270 minus 13. It gives us 257 degree. This is the angle that they were looking for. So this is 2.3. 2.3. So obviously you will get 1 mark for substitution, 1 mark for getting 13, and then 1 mark for subtracting 13 from 270. I hope it's clear. And then the last question, which is 2.4. 2.4. The horizontal component of the resultant calculated in 2.2 is equal and opposite to 9,19. 9,19. Yes, yes, is this one. 9,912 is because of we were rounding off our answers. Is similar. The horizontal component of the resultant calculated in question 2.2 is equal and opposite to 9,19 Newton force. Why are these two forces not considered to be an reaction force pair according to Newton's third law of motion? Okay, so now my beautiful learners, it is because the two forces are acting on the same what? Object. Here it is because of the two forces are acting on the same object. Remember that for Newton's second law, for Newton's third law, we must be having two objects that are acting on one another. But for the fact that according to the Freiburg diagram that I drawn here, all the forces that are acting there, they are acting on the same what? Object. So I hope it is clear. So my beautiful learners, I think for now we are done with the part of vectors, meaning the second video that will come is the video that will be based on Newton's law of motion. So please do make sure that you study this one of vectors, and then I do believe that my beautiful learners, you can do well. And then please do make sure that you visit our Facebook page by the name of Etsa, because of more videos will be posted there. The maths video, the physical science video, even the natural science video will be posted on our Facebook page of Etsa. So please make sure that you follow that page to get more information. From me, Tshaka, I thank you.